let's use some Pythagorean theorem with trigonometric functions to solve for some simple problems. So let's go ahead and start this off. So let's say we have the ground, nice grass ground. And here, let me make that back green. And then let's say there's a wall here. All right, this is nice wall. Now, let's go ahead and say we have a ladder. And this ladder, let me use my line tool again. Say this ladder stretches all the way to the top, so you're able to scale this. Now, if we have this ladder, which is blue, the ladder is blue, the wall is black, and the ground is green. So let's say we want to find for here, let me make that black actually, just because it's a bit easier. So let's say we want to find for the height of the wall, but we also want to find the distance. Let me make that a different letter. We want to find the distance here between the base of the ladder and the base of the wall. So we want to find for these distances, and let me make the Z a bit better. So we want to find these distances. And let's say that this angle here is 65 degrees. So how do we find this? Oh, and it's important to note, we'll just say the ladder is 10 feet. We'll say the ladder is 10 feet tall. Or 10 feet long, shall we say. So how do we find for X and how do we find for Z? Well, let's go ahead and use some basic trigonometry or trigonometric functions to find for one of these sides. Now, there's kind of two ways we can go about this. We can either use sine, which uses the angle x and 10 feet, the hypotenuse, 10, or we can use cosine, and we can use z in 10, which is the hypotenuse. So I guess let's use sine, since I haven't used that many times in my videos, I don't think. So we're going to input 65 because that's our angle. And we're going to say that's opposite, which is x, over 10, right? Well, this, here, let me just rewrite it. So this converts into sine over sine of 65 over 1, which is equal to x over 10. And then we could say cross multiply, so x times 1 is x. And then we'll just do 10 times sine of 65. And x is, and then let me put this into a calculator, 10 times sine of 65. And that's about approximately 9.1. So approximately 9.1. 9.1 feet. So now we know the wall is now 9.1 feet tall, right? 9.1 feet. Now how do we find for z? Well, we could use another trig function, but since we're using Pythagorean theorem with trig functions, we're going to take the simple route and just use Pythagorean theorem. Well, we know Pythagorean theorem is a squared plus b squared is equal to c squared, which is saying leg 1 squared plus leg 2 squared is equal to the hypotenuse. So using Pythagorean theorem, and I'm not the best handwriter it seems, so using the Pythagorean theorem here, a squared plus b squared is equal to c squared, let's solve for this. Well, we know one leg is 9.1, so we can say 9.1 squared plus, well, we don't know what z is, so we're going to say z squared. We don't know that right now. And that is equal to 10 squared, because 10 is the hypotenuse, right? Well, now let's rearrange this. Well, first of all, let's look at 9.1 squared. So 9.1 squared is 82.81. So we can say 82.81 plus z squared is equal to 100, because 10 squared is equal to 100. Now we can subtract 82.81 from both sides. 82.81. And now we're left with z squared is equal to, and then we'll do 100 minus 82.81, and that's 17.19. So 17.19. So z squared is equal to 17.19. Now if we get the square root of both sides, well, we can solve for z. So z is equal to, and then let's get the square root of 17.19, and that's about 4.14. So we'll just say 4.1, which is equal to 4.1 approximately. 4.1 feet. So now we know that z, that side right there, we now know that that side is approximately 4.1 feet. So approximately 4.1 feet. Should have probably done the approximation symbol here too. So that's how we can use a trigonometric function alongside with Pythagorean theorem to easily solve for some missing sides here in this little solution here. Now, in most situations, you probably wouldn't be doing this, but this is just a simplistic example to show you how you can mix between trigonometric functions and Pythagorean theorem.